welcome to the reduction of methylene blue with ascorbic acid lab. The goal for this lab is to determine the rate law for the reaction using pseudo-first order kinetics. This is the reaction that is occurring. Methylene blue, which is a blue color, is reacting with ascorbic acid. Ascorbic acid is reducing methylene blue to become leucomethylene blue and dehydroascorbic acid. Therefore, the rate for this reaction is negative the change in concentration of methylene blue over the change in time. It can also be stated that the rate is equal to the rate constant times the concentration of hydrogen ion present times the concentration of ascorbic acid times the concentration of methylene blue, all to their corresponding exponents. Hydrogen right here is included because the rate of the reaction is dependent upon the acidity of the solution. All right, how is this going to be accomplished? Because we have three different concentrations that we are analyzing and how they affect the rate of the reaction for this particular reaction. We're going to do that by first having a first set of runs in which ascorbic acid is much larger in concentration than methylene blue. This makes it so the change of ascorbic acid over time is essentially zero because it's so much larger as compared to methylene blue. And we're going to run a second set of reactions in which the hydrogen concentration is also so much larger than methylene blue that the hydrogen concentration is essentially stable throughout the reaction. So then we end up with this. This is what pseudo-first order kinetics is. We are going to set our rate constant equal to what's called K observed, and we'll talk about what K observed is in a little bit, times the concentration of methylene blue to the exponent Z. K observed is actually going to be equal to our rate constant times our concentration of hydrogen to the X times the concentration of ascorbic acid to the Y. We're going to end up graphing this so that we can determine what K observed is and then go from there to determine what the exponents are for hydrogen and for ascorbic acid. So after we gather all of our data, we can take the concentration of methylene blue, take the natural log of it, plot it on a graph of the natural log of methylene blue versus time. And then if we end up getting a straight line, that tells us that the order of methylene blue is first order. And then we can analyze what the slope of the line is, and the slope is going to give us negative K observed, which we can use to then further determine what the order of hydrogen is and what the order of ascorbic acid is. Okay, so turn on over to our chemical kinetics experimental handout so that you can follow along with the procedure. Your main objective here is to take not only the absorbance values from our spectrophotometer, but we're also going to be taking the time corresponding to those absorbance values. So if you look on, I think this is the third page, this is the list of all of the volumes that we're going to be using for each run. One run will correspond with one test tube. The second run will be a second test tube. So this tells you exactly how much of each of the reagents that we're using. And notice that there are two different ascorbic acid reagents. One is at a much lower concentration than the other. So pay attention to that because we will have to use the concentrations and the volumes to determine what the initial concentrations of each reagent is in order to solve for the orders of the reaction. So we're going to do 6 different runs. So notice I'm turning on the spectrophotometer, I'm blinking, blah, blah, blah. I've divided up the tasks among myself because I don't have a partner. And then the thing that I'm not adding until right before I start the reaction is the methylene blue. So I'm making everything ahead of time. I'm mixing all of these in their test tubes ahead of time. And then right before the reaction starts, I am adding 2 milliliters of methylene blue. So what you'll be doing is you'll be writing down the absorbance value for every 15 seconds. You have this printout, but I just wanted to reiterate what your task is. And you'll know when I stop, obviously, but for the reactions that are running slower, we're only going to record every 30 seconds. You'll see that there's a really slow change to happen in the absorbance values. And then after the absorbance readings are really small, we end up stopping. All right. So the other thing that we're going to be measuring is what's called, let me see if I can kind of zoom in on this, is what's called A infinity. So this is the background reading, that is the residual reading that's left over once the reaction is complete. And we're going to end up subtracting that from the absorbance values that we write down in order to get a more accurate reading for the absorbances. All right, let's get started. All right, so what I'm doing right now is just making all the solutions super fast. Remember, the key to this is to add the ascorbic acid and any of the hydrochloric acid before adding any of the methylene blue. The methylene blue is what starts the reaction, so we don't want to add it until right before we are going to mix it, add it to the cuvette, and then put it in the spectrophotometer. So let me walk you through how this is going to work. So I'm going to start with run 1, which is the first solution. It's the test tube labeled 1. It's the one furthest to the left in this picture. So I'm going to take this stopper off the top. I'm going to pipette out I think it's the 2 milliliters of methylene blue, add it to the test tube. That's when your timer starts. I start shaking the test tube, like mixing everything up, and then I add a small amount to the cuvette. Now, because it's only me doing this, I don't have a partner, it's kind of delayed, which means that some of these runs, you won't get an absorbance right at 15 seconds, which is supposed to be your first absorbance reading. That's okay. We're really just looking at the change in concentration over time or the change in absorbance over time. So again, we're going to add methylene blue. That's when your timer starts. Mix up the solution, add it to the cuvette, put it in the spectrophotometer, then start the absorbance readings. You're going to read them every 15 seconds. In the first run, I don't actually zoom in enough to the spectrophotometer for you to see the absorbances until I think like 45 seconds. So I give you the first couple of readings. You'll see them on the screen. Just take note of that. And I think the first reading isn't actually until about 30 seconds. So I don't get a reading at 15 seconds because I don't operate fast enough on my own. Okay, there will be 6 total runs. At the very end of measuring the absorbances every 15 seconds for 6 total runs, then we will measure the residual absorbance values, which is basically your background absorbances. So we can use that in our calculations. You'll see how that plays a part. As I said before, please have a timer out. Please have your data sheets out, either in your lab notebook or from the manual, so you can start writing down values as soon as the first run begins. So what I'm going to start off with here is just blanking the spectrophotometer so I have a baseline reading, I'm calibrating it, and then after we'll start with our first run. Remember that blue solution that's sitting in the beaker next to me? That is methylene blue. That's what's going to start our reaction. Over time, the solution is going to start looking lighter and lighter because the methylene blue is being reduced to a colorless chemical, to a colorless compound.
We were undiscovered, didn't care for one another, you and I. Thought I was okay, till something in me changed, don't know why. You got me high, but I'm sober. You make me lonely when I'm by myself. I should be free, but I'm hoping that we could be something in the end, something more than friends. Be feeling same as the beginning. Waste of time. Somehow you intruded, lost in your illusions. I was fine. You got me high, but I'm sober. You make me lonely when I'm by myself. I should be free, but I'm hoping that we could be something in the end, something more than friends. Undiscovered, didn't care for one another. You and I thought I lost my way, but you washed out all the gray. Don't know why. You got me high, but I'm sober. You make me lonely when I'm by myself. I should be free, but I'm hoping that we could be something in the end, something more than friends. In the end, something more than friends. In the end, something more than friends. In the end, something more than friends.
Fired all of the bullets. Yeah, you shot me through the heart. Casting dice and roulette. The game was set right from the start. I don't wanna go, I don't wanna know, I don't want it anymore. I don't wanna go, don't wanna know, but I keep coming back for more. Crashing down again.